is a review of what we have covered so far in the course. And the course is information retrieval. We will review chapter 1 and chapter 2, only the key parts or the key portions of those two chapters. The book we are following is this book, which is Introduction to Information Retrieval. And there is a website, formal website for the book, which has also the slides. We are following also the slides, which are by the book authors. So this is the formal website for the book and the slides. Since this is a review, we will cover some of the key parts of the course so far. We will cover an introduction, a brief introduction. And then we will talk about the incidence matrix. And then in part 2, maybe, we will cover inverted index and query processing when we have an inverted index. And then we will cover indexes when we have skipped pointers. And then in part 3 of the review, we will cover phrase queries and byword indexes, and also positional indexes. We will try to cover as much as we can of these around 6 topics. So as an introduction, information retrieval is retrieving information from documents as opposed to retrieving information from tables in a relational database. And these two slides are important to show the motivation for the course, for why we need information retrieval. We have this slide that shows in 1996, we have here the volume of data and the market capitalization. We see for the blue is the unstructured data, which is the texts and documents. Structured is like relational databases, Oracle, SQL Server. So we can see here that the data volume for the blue, which is the unstructured, is very high in 1996. And for the structured, which is relational databases and other databases, is very small compared to the unstructured data. But the money spent on systems that do retrieval from databases was very high in 1996, and the money and the budget was spent on unstructured data was almost zero, almost nothing in 96. Now we have in 2006, after 10 years, the situation is different. We have this one, both grew in size, but the money that's spent on systems that do document retrieval and information retrieval is more now, in 2006, is more than what was spent on retrieving from former relational databases. And we can see there are so many companies that have entered the market that do information retrieval from unstructured data. So this is the first part, which is the introduction to the course. Now to do information retrieval, we have from documents, we have some structures that help in the process of doing information retrieval. One of them is the incidence matrix. We covered this in the course. The way it works is we have documents. The columns are documents. These are document titles. And we have words in documents. So we form a matrix from document names and words in these documents. We have ones and zeros. One, whenever the word exists in the document, and zero, whenever the word does not exist in the document. So it's a matrix of ones and zeros. And this is built offline. not at the time when the user comes and requests the data. So this is built offline. Now, when the user comes to request data, what we do is we do bitwise ANDing to find documents that contain the data. So here, let's say, for example, this query by the user that says Caesar and Calpurnia and not, which is down here, this query, Caesar and Brutus, but not Calpurnia. What we do is we have Brutus is one, we have a vector for Brutus, which is 110, 110, and what?
100.
100. This is Brutus. And the other one is Caesar.
1101.
1,
1
1,
01
01,
11.
11. And then and not Calpurnia. Calpurnia. What is Calpurnia? Is 1, 1, 1, 1, 0, 1.
No, 0, 1, 0.
Okay.
0, 1, 0.
0, 1,
0
0.
0
Uh-huh.
0 0.
Okay. So this is Calpurnia. So what we do is we do a bitwise ANDing between the first two. 1 and 1 is 1, 1 and 1 is 1, 0 and 0, 0. 1 and 1 is 1, 1 and 0 is 0, 0. And then because we have a not here,
Complement.
we do a complement
1
for
0
this one. So this is after the complement is 1, 0, 1, 1, 1, 1. And then we add this one with the complement of Calpurnia. So what we get here, the final answer is 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, and 0, 0. So we have the first document and the fourth document. The first document, Antony and Cleopatra, and the fourth, which is Hamlet, contain are basically they are the answer to this user's query. So this is how incidence matrix works. Okay, the other structure that is better, that's an improvement over the incidence matrix. The incidence matrix has a problem is that when we have a huge number of documents, a very huge number of words, the matrix will be very huge. And what happens is we have many more zeros than ones. So we call it sparse matrix. We have so many zeros, but very few ones, and we are really interested in the ones, not in the zeros. Because the zero means the word does not exist. The one means the word exists in the document. So a better structure is called an inverted index, which we also covered in the class before. And here is how it looks. So we have Brutus. It's basically it's a dictionary of words. They are sorted alphabetically. And then there is a pointer to the document IDs that contain the word. Document IDs that contain the word. So what this means is that Brutus exists in 2. It does not exist in document 3. So in the incidence matrix, you will see Brutus and document 3 with a 0. That one is not here. So that's how we save space, because we are not concerned, we are not interested in the zeros. Brutus does not exist in 5, 6, 7. It exists in 8. So this is the linked list of documents that contain the word. The dictionary is sorted. Also, the document IDs are sorted. So this is the inverted index idea. Now, how this index is built, of course, these are called postings. This is a posting list for Brutus, posting list for Calpurnia, and so on. This index is built offline, not at the time when the user issues a query, and it goes through several steps to build the index by scanning the documents, finding the words, and then sorting, and then putting them together. Finally, we get to this format, this form, which has the final index. This is the inverted index for 2 sample documents, and basically it shows the term or the word in the document, the document frequency, which is the number of documents that contain the word. In this case, like ambitious is one document, which is document 2, while, for example, the exists in two documents, and this is the 2 documents here. So this is the shape of the final inverted index after the system goes through a set of steps to build it. Now, how do we do query processing when we have an inverted index? How do we do query processing? Okay, how do we do query processing? There is a special algorithm for that, which is called the intersect algorithm. Basically, we have 2 pointers. We have 2 lists. The system creates 2 pointers and goes through the 2 lists and does the intersection. Now we want to go through how the algorithm works. This is an animation that shows how it works, and now we just go through it and then we explain step by step. So 8 and 8 is a match, so it goes with the answer. The left side is the answer. 2 and 8 is the matching, is the document. 2 and 8 are the documents that exist in this list and in this list. 2 and 8. So the answer to the query that says Brutus and Caesar is only these 2 documents, 2 and 8. So 2 and 8 are really the intersection of these 2 lists, meaning that the documents that exist in both lists. So this is called the intersect or the merge. We will go through it in more detail in the next part of this series of review lectures.